All right, hey guys, this is what we did on Friday. If you were unfortunate enough to miss class, we started out the period by, renewal by Anderson. Go away. What else is coming? Home Employment Network. Glad I'm working from home. Anyway, we started Friday looking at some of these AP problem sets that we sort of started when we were for homework the other day, and we really hadn't had a chance to go over any of these, and I felt like it wasn't really doing you any favors by leaving these things kind of on the table. So here is one of the first ones, and they're giving you a cumulative relative frequency histogram, which is sort of the basis for an ogive, for 40 scores on a test given in an AP statistics class, and it says which of the following conclusions can be made from the graph. Well, that's not much to go on, so I guess I'm stuck checking all of these just to see which ones are right. So I'm going to check A. It says there is a greater variability in the lower 20 scores than in the higher 20 scores. All right, well, if your thinking cap is on, that's telling you that you're at the median because that's half the scores below and half the scores above. So I thought, okay, let's just see what we can do then with the median. So I figured I better find it. So let me go ahead and just, all right, I'm trying to get a straight line here. So let's see. Okay, still not doing it. There's a trick to this. This ought to do it. All right, so I'm going to draw over to the first class halfway through, and then I'm going to draw down from there. And it's pretty much spot on at 80. So my median equals 80. So 20 of the test scores represent what's below that, 20 of the test scores represent what's above that, and they're talking here about variability. And I think some of you guys aren't really sure what we're talking about with variability. That's just another way to say spread in this particular case. So if you look down here, we have got 20 test scores from the beginning up to 80, and that's going to give you a range of 30 to 80 as far as scores go. And then you've got another 20 test scores up here, but they only range from 80 to 100. So that's a spread of 20, but that's a spread of 50. So A is correct. There is actually a greater variability in the lower test scores. Let's check the other ones. So the median test score is less than 50. No, it's not. It's right here at 80. So that's out. 60% of the students had scores above 80. Nope, that was 50%, right? So that's out. If the passing score is 70, that'd be right here, then most students did not pass the test. Well, 50% of them did, and then you're adding on this little piece right here. So that's actually a majority of them. So that's out. And then this last one, I really can't explain it because it doesn't make any sense. Horizontal nature of the graph for test scores of 60 and below, so I guess we're talking about these here, indicate that those scores occurred most frequently. I don't know. First of all, it's not totally flat, but even it's sort of flat, but they're really not occurring too often. I mean, these are a few extremes that are making this that's why they're so short. So this thing is out. So the answer is A. I think that's pretty clear. So let me go ahead and go on to the next thing that we talked about. So let's see, it's here. And let's see if I can get rid of that window. View tools, show and hide, tools paint, there it goes. All right, so you'll remember this from the homework. I think it's homework 11, maybe 12, one of the two. Anyway, this is about some bad chemical that they're trying to clean up in their 3 rivers, and they're testing it, some pesticide I suppose it is, aldrin. And they want you to go ahead and compare the distributions of the concentration of aldrin among the three rivers. So you've got to comment on SOCs, shape, odd characteristics, center, and spread. Now it's a little tough to do it because if you need some sort of point estimates or IQR or something where you need the real numbers, what is this number right here for this median for river X? I don't know, 5.3? But if you want to assign a number that's close, that's fine. Let's start out with the center. That would be the median. Well, the median for river X is bigger than the median for river Y, and bigger still than the median for river Z for aldrin concentration. So you keep your context, and you don't need to actually put numbers to it if you don't want to. Just say that one is bigger than the other. I think I said that river X was the largest at about 5.3, river Y was about 5, and river Z was about, 4.4, 4.3, whatever. All right, let's look at shape. Now, box plots don't convey shape, but they can convey skew. So river X is skewed to the right. River Y is fairly symmetric. I realize that this isn't perfectly matched up to this whisker, but that's close. So approximately symmetric. River Z looks like it's skewed to the left. So that takes care of that. No odd characteristics. So shape, odd characteristics, center, and spread. Oh, the spread. Now you can try to quantify or put numbers to the IQR. But if you just say that river X is the most variable, and then river Y would be the next most variable, and river Z would be the least variable, they love that term variable. Again, I think their scoring guideline puts approximate IQR values on it, but those things match up to what I just said. So there's a scoring guideline after that. We'll look at it. They wanted you to make a stem plot for the actual data, and it's a little weird because it's not integer values, but it is discrete because it only goes to one decimal place. So when you do that, it should look like this. Now you got to put a key, right? So line 4 represents 3.4. Don't bother putting a decimal after every single one of these numbers. It's going to utterly confuse your reader, okay? So this is what your stem plot should look like, and they put a title on it, and there's your key. And you can read the solution in part A, and they're very short on numbers. They did do like percent comparisons for various things based on your quartiles, but I don't think that's really in the scoring guideline. And then they ask you in part C, well, what's the difference between this graph, your stem plot, and this one? I think it's for river X. And what you see in river X is a gap between 56 and 73, which cannot be shown in a box plot. They just don't show that much detail. Now, I did have a student say, well, you can pick out the mode from here, and you can't from the box plot. And that's very true. But, you can do that in any comparison of a box plot with a stem plot for any particular data set. But this one, you're looking at a specific pair, and so you want to look at what's uniquely different between both of them, and it would be that gap. All right? So the scoring follows, and I'm going to try to get this up on the website, and you can read it for yourself. You can see what's essentially correct, partially, and incorrect, and figure out kind of what you might have scored on yours. So there's that. So the next thing I did was I just broke loose the kids to go watch the video that's posted. It's the very first one, and it's in Friday's announcement. It's embedded there. It's a Decisions Through Data. It's their volume number 6, or film number, I think it's number 7, film number 7. And it's really very good introductory material for chapter 2. It takes you from density curves all the way up to z-scores and comparing z-scores and all sorts of things. So What we're going to do, what you should do, is watch that thing, and you get a kick out of the fact that it's circa 1975, excuse me, with disco dancers and weird hairstyles and everything. But the material is actually really good. So watch that. And so then what we did was we came back and I talked about density curves. So I think I'm going to have to pause for a sec. And yeah, I'm going to go ahead and pause. All right, so here we are, and this is not in your packet. You can find this in reprints. It is going to be the homework for tonight. So I'm going to kind of give you a little bit of a start with it, and this is going to kind of be our introduction to just a generic kind of or irregular density curve. And what you need to know is if something is told to you to be a density curve, then what they're saying is the area under the curve is equal to 1. Now this line up here, I know these are two line segments and they're not exactly a smooth rounded curve, but it's still considered a curve mathematically. It's the area under it that's in this kind of pumpkin color that represents the density curve. So you read it from the x scale on up, and don't read it across left to right, because we want values below the curve, proportions under the curve, not ones to the left of the curve. All right, so if this guy is a density curve, that means it's scaled to where the area is 1 in every case. So if they say it's a density curve, take it to the bank that the area under it equals 1. We're going to verify it for here because we're not told necessarily that this is a density curve. It may just be a generic curve. But if we can find that the area equals 1, it's a density curve. And then we can cut it up and get proportions or percents or anything related to something out of 100% or 1.0, depending on what they're asking. So we can get probabilities if it's a density curve. They're very, very powerful for what we need to study. So what we can do here is this is going to be a trip down memory lane for your geometry. And we can break this into this rectangle, this sort of on the lower part here. That's easy because for a rectangle, area equals length times width. And then we have this triangle here, and we know the formula for it. You guys have dealt with these formulas for like forever. So area is 1/2 the base times the height. So if we can get the two areas and add them up and get them to equal 1, we have a density curve. So let's start out. For the rectangle, the base goes up to 0.8. So the area total will be 0.8, and then the height of it will be 1. So that's 0.8. And if we can get this triangle to be 0.2, it's gold. So 1/2 the base, that's going to be 1/2 times 0.4 times the height, that'll be 1. And I think you're seeing it already. That'll be 0.8, and that's half of 0.4, which is 0.2. So that equals 1. So this is confirmed. It is a density curve. So now that we have that, we can go ahead and we can start chopping it up and finding proportions of the observations. Let's just say this represents some kind of graph with a distribution for data, and we now know 100% of the data is in here, and we just have to find out the proportion between certain values. So between and including 0.6 to 0.8, well, that's going to be this rectangle off here on the right, this one little rectangle. So 0.8 minus 0.6, the length is going to be 0.2, and the height right here is going to be 1. So that proportion of that entirety is 0.2, or 20% of the observations. Now, I'm not going to write 20%. I'm just using that as a verbal for you to learn. But we do have to report in the kind of metric that they want. Okay, so between 0 and 0.4 would be right here, okay? Get rid of that because it'll be in the way later. And 0 to 0.4, well, the length, it's going to be a rectangle on the bottom, so it's going to be the sum of two things. And so let's see, that'll be 0.4, and the height of that rectangle will be 1, plus the triangle, 1/2 the base, that's 1/2 0.4, times the height is 1. Okay, and so that will be 0.4 plus half of 0.4 is 0.2, or 0.6. Or 60% of your observations are going to be right here from 0 to 0.4. And you see how I'm cutting up and not across? It doesn't make sense to cut across. Kids try it though. All right, so here's where it can get complicated. Between 0 and 0.2 is this interval right here all the way up. So it's the rectangle below, which is easy, but then we've got this shape right here, right? And that's a terrible drawing. Let me get rid of it. That's a trapezoid. Okay, now you can cut it into a triangle and a rectangle if you want, but remember the area of a trapezoid, isn't that 1/2 the height times the sum of the bases? That'd be b1 plus b2. Get that to right. All right, and the bases are going to be the parallel sides. So it's this piece, and that makes the base right here on the horizontal. Okay, now the issue here is getting the trapezoid, because you kind of need to know what this point is right here, at least the y value, because it looks like it's halfway in between. And if you're able to explain it in a cogent way other than the fact that it looks that way, then that's fine. What I ended up doing was I found the linear equation for this line segment, because you have a point here and you have a point here that you can read, so you can get the slope formula and then figure it out from point slope, plug in 0.2, and if this is going to be 0.2 comma 1.5, then you know that this is going to be halfway up, because this is the 1 and this is the other 0.5. All right, so you have to show that, because in geometry that pictures are assumed to not be drawn to scale. So I am going to leave you with this one. All right, can't do them all for you. So I will get number 2 set up. So this says it is a density curve, although it's not drawn. It has a uniform distribution over the interval on x from 3 to 12. So let's just put some marks here. So 1, 2, 3, 4, 5. Sorry, this is taking a little while. I just want it to be accurate. All right, so it's from 3 to 12. And this height is how high it's supposed to be. We just don't know what this value is right here. So I'm going to go ahead and draw this thing, right, kind of up to here. Oops, it always tilts on me. You'd think after all these years I would have perfected this program. All right, that looks like garbage, but I'm not changing it. Let's try this one. Okay, that looks like garbage, but I'm not changing it. Let's see if I can get a straight line here. At least I got the straight line. Okay, so this is uniform. Uniform looks like a rectangle. And remember, the area here is equal to 1. But area is also length times width. And so we know the length of this. It's from 3 to 12. So our area, which is 1, is going to equal, and let's just call this for the moment y, this height. That's going to equal 9 times y, right? And to solve for y, you just divide by 9. And so y here is going to equal 1 over 9. Because think about it, 1/9 times 9 is 1, right? So that's how you figure this thing out. And now they want you to get the proportions that are greater than 7. So that's right here. And let's see if I can actually get it to draw straight. This is always fun for me. Okay. What is it with this? Some days it works every time. All right, there we go. So it's from 7 to 12. And so we're looking for this right here. And this will be 1/9 here, and this will be 1, 2, 3, 4, like 5/9 or something like that. Actually, let's see, greater than 7. 1, 2, 3, 4, 5. I guess 5. Maybe my key is wrong, but anyway, you can figure that out. And then you have to do between 4 and 10, which is just a different rectangle. When you get to the back, you're going to have to kind of struggle through this. One of them is a triangle, and the other one, you just have to read it and draw it yourself. I have my key up. I don't really want you to just, use my key necessarily. I want you to try. You've got 3 days, and this is all I'm asking you to do. So see if you just can't set aside 30 minutes to drill down deep into your geometry and figure it out. And if you really, really get stuck, then you can go ahead and look at the key. But yeah, so that's it. That's what we covered, and I think I will let you go, and I will see you on Tuesday. Bye.